Now, and just remember, the tutorial on Monday. We'll look at those trigonometry questions and, other stuff from the chapter, like the graphs maybe, process stuff. So what we're going to look at today is the graphs, but
Thanks for your
for you. Okay. So if you just put your laptops away for the moment. Yeah. So in second class, we'll get it. Ready to separate anybody on group of 4? No? Are you sure? For real? For real? Alright. So what we're going to look at in today's lesson is the opposite. We have the graph and we want to read the graph and find the A, B, C, and D. Okay, so it's just going backwards now. So let's go with this for a second. Right. So just before we start with the graphs, what's that? I think the tutorial on Monday we could use this time. I think the tutorial on Monday can be the trigonometry practical problems and these graphs, or is it the equations? Do you have questions on the equations? I'd prefer to leave it for Monday so we can give more time to prep in the assignment. Yeah. Reading the graphs. Okay, so let's just take, hey, come on, listen now. Let's just take this graph as an example. So just a little bit of theory before we start. If this was a sine graph, the maximum should be where? And the minimum? -1. If it was sine or cos, it should be 1 to -1. Yeah? So 1 to -1. How big is that? 2 units. Okay. What happens when you have an A in front? If you have an A sign, it increases it, doesn't it? So for example, if you have 2 sine, it goes from -2 to, how big is that? 4 units now. What was it originally? 2. So it's 2 times bigger. In other words, the A multiplies vertically. But you knew that already. But working backwards, what you could do is, if you knew the max and if you knew the min, the max minus the min, that should equal 2, shouldn't it? Unless I multiply by A. Then in that case it should equal 2A. In other words, if you just do max minus min over 2, that's what the A will be. Okay, so the A is the maximum height divided by the minimum height over 2. That's the A. So for example here, if this was 6 and let's say this was 2, 6 minus 2 is 4, and 4 divided by 2 is 2. So in this example, the A would be 2 in this one. Oh, I should also say, these formulas, it's not the way I prefer to do it, but from past experience, it's the way the students prefer to do it. So I'm giving you these formulas because I can't remember, but 1 year students asked, are there formulas? And I said, yeah, but the problem is the formulas aren't in the formula book. But the students much, much prefer to remember the formulas rather than the other way I had to show you. Okay? So what I'm saying is these formulas are not in the formula book. They have to be remembered. Okay? So that's how you can go about finding the A. So now, next we'll look at trying to find the B. Okay. So now the B. So again, let's just take something like this. Oh, no, not quite like that. Something like this. Hey, come on, guys, come on. Something like this. And the B controls how big it is horizontally, doesn't it? So if the B is 2, as an example, what happens? Compresses by 2. Okay? So you pick anywhere on the graph if you know it. So for example, here we can say this is the start. And then when does it end? It would end, for example, back here. In other words, this is one cycle. But it doesn't have to be there. You could pick, for example, and let me draw it again, sorry. I could say it starts at the top, and then it would end here at the top again. Okay? It doesn't matter. You find one cycle. So we call this the start, and this one then the end. How big should that be if we're using, say, radians? 2 pi. And if we're using degrees? Yeah, so we have end minus start should equal 360 degrees. Unless we have a B. So for example, if it was 2B, will it be 360? No, it would be 180. And if it was 4B, it would be 90 then. Okay? So the bigger the B, the smaller it will get there. So it won't be 360. What it should be is 360 divided by B. So like I said, if B was 2, it shouldn't be 360, it should be 180. So the end minus the start will be 360 over B. So in other words, B is 360 over end minus start. That's if we want to find B. Well, the 360 is because one sine or cosine graph should be 360 long. Yeah. Unless we have a B. If you remember from the last class, the B changed. Yeah. So, if the B was 2, how long would it be? Yeah, it'd be 180. So you can see here, if the B was 2, what's 360 over 2? 180. So the end minus the start, that's how long it is 180 instead. So this is the formula from the last class. And then I've just rewritten it like this. Okay. So you can see they're not very difficult formulas. And of course, if this was radians, that 360 will be a 2 pi. That's all. That's different. Okay, we're going to the D next. Okay, the D. So the D, what does it do? It moves it up or down. Okay. Now, let's give some examples. If I had sine, what's the maximum? 1. 2 sine, 2, 3 sine, 3. So if you look at the maximum, it can kind of tell you if it was moved up or down. For example, if I have 3 sine, it should finish at the top at 3. But what happens if it finishes at 4? What does that mean? It's moved up 1. And if it finished at 2, it's been lowered 2. So this should finish at the A. So we need to know what the A is. So you have to use the A formula first to get the A. Then you see how different it is to what you expected. So we expected at A. But let's say it's not at A, it's at a different number. We have to see how different they are, don't we? So like for example, if A was 4 and we had 5, then how much is it being moved up? 5 minus 4. It's being moved up 1 unit. Okay? If I had A is 4, but it was at 3, if I do 3 minus 4, what do I get? Minus 1. So the D is minus 1 is being lowered. Okay? So in other words, it's what you expect minus what it is. So how can we write that as a formula? Well, we'll just write it like this.
Won't we flip the unit at
Oh, don't confuse me just yet. No, because let me just write it down and we'll have questions. The D is what we expect. We expect the A minus max. So, for example, here, let's say, I don't know, this was 6 and this was 1. No, sorry, what did we have? 2. In this example, what did we say the A was?
3, 2. Max.
No, what's the A? From Formula 1, what's the A? Yeah, max minus min over 2. What's that? 2. So, if I do, oh sorry, I might have this backwards. If I do 2 minus 6, what's that? Minus 4. Sorry, so I have this the wrong way around. It's max minus A. Let me just fix that. Max minus A. Okay? So in that last example it was 4. Now the last one to get is C. And the easiest way to get C, although there are formulas in the exam, it never works out nicely that you can use the formula. Instead, I'll just say get C last, and to get C you sub in a point. Just like what we did in chapter 1. This gives us the C. So you take a point on the graph, you sub it in, and find the C. It's the easiest thing to do.
What does it do? What does C?
The C controls the movement left and right. But it's affected by the B as well. So it's just easier to do it like this. I'll do the first one as an example. Now before I start, I should also point out there are more than one answer. But there is more than one answer. And that's okay. Alright? If you look at the first one, you have a graph. There is more than one formula that will make that graph. In the exam, that's not important. You just need to find one formula that works. Okay? So don't worry if the answer doesn't match perfectly with the back, or if it doesn't match perfectly with the marking scheme. The reason for the different answers is because if you think about it, a sine graph and a cosine graph, they're nearly the same. What's the difference between sine and cosine? The starting point is different. So you can change a sine into a cosine by just moving it a little bit. So what I'm saying is these graphs, you could make the same graph using a sine or a cosine function. Also, every 360 degrees, what happens to the graph? It repeats itself. So again, the C has many different values to make the same graph, okay? The C that moves it left and right. Because if you have a graph, and if you move it 360 to the left or to the right, is the graph the same or different? It's the same. Okay? So again, I'm just saying that don't worry about getting the answer exactly to the marking scheme. In the exam, they give one answer in the marking scheme, but it's not like that's the only answer. Okay? So let's have a look at the first one. So the first one, how can I find the A? So this is the first one. Well, what's the formula for A? Max minus min over 2. So here it would be 3 minus 1 over 2, which is 2. Alright. What do we get next? I think is the B, isn't it? Which is, what's the formula? But in this case, 2 pi over end minus start. Okay. Now, look at the graph. Choose an easy start and end point. So if I look at this graph, let me see. Yeah, I think...
5 over 4. 5 over 4 and minus 5 over 4.
No, because that's not quite line enough.
Yeah.
I think I will go with... Well... pi over... Yeah, if you look at this graph, 5 pi over 4 to pi over 4 is half. So times it by 2. Yeah?
Are you doing 1A?
Yeah, the very first one, yeah.
What will be the 2 pi? It's a 5 pi.
Oh no, I'm using my formula for B. Remember 360?
Oh, yeah.
But it's in radians, so it's 2 pi. Yeah. I think...
You can derive the point like minus 5 pi over 4
No,
plus.
I know what I'm doing. We just said it a moment ago over there. Hey, come on. Please. Look at the graph. If you look at pi over 4, the graph starts at, that's a minimum, isn't it?
Yeah.
And then 5 pi over 4, what's that? It's a maximum. So if I was to use the pi over 4 as a starting point, I have to go up, down to the next minimum. But you can see it's cut off from the graph. But that's okay. You just need to listen. That's okay because pi over 4 to 5 pi over 4, that's half a cycle. Okay, if you think about it, if the graph goes from min to max to min, and the end is cut off, min to max is half one full cycle. So we do 5 pi over 4 5 pi over 4 minus pi over 4. What's that? No, it's pi. But then I need to multiply it by 2. So what's the length then? It's 2 pi. So here is 2 pi, so it's 1. Now look. Huh? Yeah, sure, yeah, I'll draw it on the board. It's like, are you looking up? So I'll just explain my logic here. So let's take a graph like this here. When you do end minus start, basically I want to know how long is the graph. What's the period of the graph? So in other words, I want to know how big these pieces are. Now, what's happening in this graph, you'll notice, is that this piece is actually half one period. Why is that important? Because in the graph, in the book, if you look at it, it goes like this. You see, if I start here, I should end back here. But you can see that this is not on the graph. That's okay. That sometimes happens in these graphs in the exam too. But if you go from the lowest to the highest, that will always be half one full cycle. So if you can't know the total, but you can know half the total, then just multiply the answer by 2. Yes?
So can you just use the max?
The max? Oh, max to max. But on the graph, it's not labeling what the max is on the left. You see that 5 pi over 4 on the left? That's not located in the center of the peak. So if it was, yes, we could go max to max. That's true, but we can't here. Did you hear that? What, yes? No, we don't. In the formula, we don't. We don't. So the same as on the graph, which is true, why couldn't we go from max to max? And the answer is, if you look at your graph, I don't tell you where the max is on the left. You see, it's not labelled on the x-axis. There is a max on the left and the right, yeah?
No, wait, you can't get this point because you have this and this. So this was the max, so you have to.
True, yeah, and that's another way to do it as well. That's right, yeah. So you can take the middle of these two to find out where the max is. Yeah. There's more than one way. So we have from earlier half and then multiplied by 2. But another way, Ali was just saying here, is if you look at the left, look at the graph at the left, you see where it says minus 5 pi over 4 and pi over 4. The minus pi over 4 and minus 5 pi over 4. The maximum is in the middle. Can you see that on the graph? So if you got the middle, no, but you can't be sure, but I think it is in this graph. But if you got the middle of those two numbers, You could find where the max is on the left, and then you know where the max is on the right. So there are many, many ways to look at this graph. All you need from the formula is how long the graph is. Whatever way works out best for you, that's fine. This graph will be 2 pi long. That's what we've established. So we have the b is 1. Then we'll go on to the d next. So what's the formula for d? Hang on, where's it gone? Yeah, what's the d? Maximum minus a. What's the maximum here? 3. And what's the a? So the d is 1. So far we have this as our formula. Y equals a sine 1 bracket x plus c bracket plus d. Please note this is not in the same form as what I ask in the question. So before I finish, I have to do some cleaning up, but we'll worry about that later. I have the A, B, I have the D as well, don't I? What was the D? 1. I have the A, B, and D, and I want to get the C. How do I get the C? Substitute in a point. The point I'm going to substitute, if you look at the graph, is 5 pi over 4 3. If you look at the graph, you can see that's a point on the graph. I'm using the maximum, that's right. But of course there are other points to use. I'll just use that one. So if I sub this in, I get, and I know the A as well. What was the A? 2. If I sub this in, I get 3 equals 2 sine 1 x plus c plus 1. And you can see that we can find the c here. It's like what you did in the last class, the trigonometry equations. So here we'll get 2 equals 2 sine 5 pi over 4 plus c. 1 equals sine 5 over 4 pi plus c. Sine inverse 1 equals 5 over 4 pi plus c. By the way, how many answers does this have? Well, you know it has 2. But we only need 1. So we'll just get one answer. That's all. So what's sine inverse of 1? It's 90 degrees, but in radians it's pi over 2 equals 5 over 4 pi plus c. So c equals, what's that please? Pi over 2 minus 5 pi over 2. So it's 3 pi over 4. It's a half. 2 quarters minus 5 quarters is minus 3 quarters. Okay. Yes. So now let's look at what we have. Y equals a sine b x plus c plus d. Now you might think that's finished. Yes, it is nearly finished. Which one? No, but that's what I'm saying now. The answer I got, I need to make it into the form of what they have in the book. Yeah, just multiply the 1 in. What's wrong, Kyle?
Why do you have b times the full bracket?
Were you in our last class with the graphs?
No, but I've already watched the video.
Yeah, so what I'm saying is, the way I have it written now is what you might call a standard form. It needs to be in this form so I can use all the rules I've been using today and in the last class. So when I find my b, that's actually different to the b in the equation. Now in this case it's the same because of the 1. But let's pretend that the b wasn't 1. I only wrote the 1 in there because most of the time it's not 1. This isn't finished. What I need to do to finish it is multiply the 1 in. Okay? So you can see that the b is 1 and the c is still the same. But if it wasn't 1, if it was 2, then what's the b? 2. But the c is no longer 3 pi over 4. It would be 6 pi over 4. Okay? Look at this and then look at the question. You see how in the question I've expanded, whereas here is not expanded. In other words, my b and my c here won't be the same as the c here until I expand it. Then it's the same. Okay, so here I get y equals 2 sine x minus 3 pi over 4 plus 1. Now I know it's the same, but it's not always going to be 1. So this is the a, this is the b, this is the c, this is the d. I'll go back down. So I'll just repeat that because it's important. This c here is not necessarily the same as what's in the equation in the question. We only discover its true value, its true form, at the end after we multiply the b in. Do you remember in the last class I told you what's the first thing you do is you divide out the b. Do you remember doing that? So when we were drawing our graphs, we always take the b out and put in the brackets. I'm doing the opposite now. I'm putting the b back in. And now it's finished. So that's the answer. A, B, C, and D. That's the four of them. Students find this question in the exam difficult, okay? Every year students find this one difficult. All I can say is you just need to practice them. The good news is it's not too common in the exam. I've seen it in the last maybe 14 exams. I've seen it 3 times. What's much more common in the exam is the drawing that we did in the last class, which is better for you because I think that's okay to draw. No? This one here, though, is not so common, but it does come up. Okay. Now, I don't know how this compares to the answer at the back. What do we get at the back? Yeah, minus 2. Yeah. No, it's not, but I said there's more than one answer. So what I'm going to do now is I'm going to draw a graph of my answer and then this answer here, and we'll see what we get, okay? Now, the a here is minus. Did I say in the question that the a is minus?
Why is it minus?
No, because there's more than one answer. So, for whatever reason, I gave the minus answer here.
Would it be nice to be flipped?
It would be. It would be, yeah. So, it may be... Well, we'll look at the graph now. Can you read out my A, B, C, D? So, what is it? Y equals 2 sine bracket x minus 3 pi over 4 plus 1. Hey, look up. Okay, so let me just get the range right here. Okay. So you can see that my graph, my answer is the same as the graph there. I've just done it a little bit further. Yeah. And let me just stretch it. It is a bit, isn't it? There we go.
That's minus, the maximum here is minus 2.
The maximum here is 3, and my maximum is also 3. And the minimum is minus 1. Yeah? It's the same, isn't it? Yes? Now what I'll do is I'll type in the equation at the back and we'll see what graph we get. So at the back now, y equals a sine b, which is 1x, plus c plus d. And it's a sine here? What's happened? It's the same. So this really demonstrates my point quite well. Many equations can make the same graph here. Flip it.
How is it flipped at the same?
I'll let you think about that. I think it'd be much more important if you try to figure that out. Yeah. Also, just keep in mind that in the second one, there's something else that's different. The C is different.
That's why it's the same.
Yeah, well, watch, I'll show you here. Look up. Look. Watch. So here, for example, is a sine graph. Okay? I would like to move this a little bit left or right and flip it so that it's still the same. So here, for example, is y equals sine x. Now, in a different colour, let me move this to the left. So I wanted to go this point to move over to here, and then this point to move over to there. What makes it move left or right? A, B, C, or D?
B.
C. Yeah, C makes it move left or right. So, who remembers how big a sine graph is? It's 2 pi. Who knows how big this piece is if I go from here to here? It's pi. So if I move this graph to the left pi, that's y equals sine x plus or minus pi? Plus pi. So the graph now, this is here, and it goes up like that, and then goes like that. So I've moved it to the left. Now, what would happen if I put a minus in front of this? This red graph gets flipped. So this point is now up here. And what graph do I get? The same graph. So you see, with a suitable C and a suitable minus, well, not suitable minus, with a suitable C and a minus, it can cancel each other. So the minus is cancelled by the different C.
We're not too tired to know how to get it.
No, but I'm answering the question you asked me.
I understand how it's like the same.
Yes,
I'm not
but
too
you're
tired to
not.
get that.
No, this is just for your own personal growth and benefit, yes.
That would be a good question.
It would be, yes, yeah. But they wouldn't ask you something like this. Yes, indeed. Okay, so what we'll do is, I think I'll just let you try 1 or 2 of them, and then we can work on the assignment, okay? So, why don't you try for yourself, no, hang on, you've got 6 ones I've taken. I want to pick 2 of the ones. Hey, Charles, Luke, mark these 2 questions, please. I'd like you to try B and D. And can you look at the answer? Mo and Lisa, please. Look at the answer. This is yours. There is some important vocabulary in the answer. Those A, B, C, D's, they have names. A is called amplitude, B is called period. Yeah. Now, guys, can I ask why nobody respects me and thinks it's okay to talk when I'm talking? I'm trying to tell you something important here for vocabulary. Now, in the exam, it is possible that they might not say find B. or find C. Sometimes they could say find the amplitude. I've seen that a few times. Or find the phase. So it is important that you know this vocabulary, because they might not use A, B, C, D. And it's on the back. Okay? And see that period? You see period?
Yes.
That's not B. That's the period. That's how long it is. Okay? So if you know the start and the end, what's the B? It is 2 pi over start end minus start. This here, end minus start, that's called the period. How long it is. That's called the period. So we have this formula. B equals 2 pi over the period. So if they ask for the period, that's just 2 pi divided by B. Okay? Now I think at the back, I go period is pi or 2 pi. Yeah, that's fine. Yeah.
Is it all the radians?
No, it could be radians or degrees. I don't know what I did for these questions. Are they all radians or are they all degrees? They're all radians? Okay. Yeah. All right, work on those two, please. Did I tell you which two? I did.
Yeah. A is amplitude, right?
Yes.
So C is 8, D is 10,
Yeah.
and here is not.
No, but it's related. Yeah.
Then we see that period equals to wavelength.
Period is the length.
Wavelength.
Oh yeah, very good. Wavelength. We don't use that vocabulary, but it's the same thing. Wavelength.